boleh ngerokok. Ya, mari kita sebenarnya ke farm buatan, sepertinya laboratorium. Nih, jadi tempat kita nguji kipas dan sebagainya. Sebuah Academy ini masih punya Skov, satu grup. Ya, kontrolernya. Masuk ke dalam. Oke. Kita lihat pen feeding, sorry. Juga ada nipple, juga ada timbangan otomatis nih. Jadi ini semacam miniatur farm ya. Nih. Sensor
suhu, kelembaban sama CO2.
Ya. Tuh. Nah, ya. Teman baik lihat di sini ada ya kipas tadi. Kemudian inlet. Inlet, side inlet ya. Skov Academy. Side inlet. Itu kipasnya nyala tuh. Kita masih lagi diskusi. Lighting. Atapnya juga ada sudah insulasi.
I will open the flat completely. Yeah, it's better to see from inside. You can just go inside and see it.
Oh ya, sudah terbuka ya. Tadi di setting sama Pak Johannes. Sudah terbuka sekarang. Ya.
You can see that I have asked it to open completely by setting it into manual mode. I will show you on the display how that is done. But the flat is opened using an approach that we call relay with feedback. I can, on a screen when we come back to the training room, I can show you more in detail how it works. But actually you have two relays. So it's a DC motor.
Ya, di sini.
If you have plus on the motor, it will not run. If you have minus plus, it will run in the one direction.
Yeah.
And if you reverse the polarity, it will run in the other direction.
Yeah.
Okay?
Okay.
So this is what we're doing. We have these two relays and we can make it run the one way or the other way or stop it.
Okay.
Okay? Then we have a feedback. That's a potentiometer or a voltage feedback from where the flat position is between 0 and 10 volts.
0 and 10 volt.
Yes, but because there is some inaccuracy in this kind of feedback, the computer needs to know what is 10 volt, is that 10.00, is that fully open or is it maybe only 9.9? And to fix that, also in the closed position where we expect 0 voltage, maybe it's 0.1.
Okay.
To do that, we do calibration of the flaps. We can do the same calibration with the actuator pulling here,
Yeah.
opening and closing the side inlets. And the approach to do it is exactly the same. And you should do it frequently.
Frequently.
One time a year, maybe. One time a year.
Okay.
That is done routinely when we do service on a complete installation. Then we calibrate all the actuators, okay?
Okay.
I will show it to you calibrating this one. So let's go outside and see how it works. I have now put the flap into manual mode. I will show you where in the menu the manual mode is. Can you all see the screen? Is it big enough, or should we take the other one? Oh, we should deal with this. It should be okay. In the burger menu, in settings, down in the service part, in the technical part, there is manual auto. And here you can see, if something is in manual mode, it will be visible in this menu here. Yes, the air outlet 1.1 requirement and fan speed are both in manual mode. Okay? Can you close the door, please? Then we keep the heating in there. Now I take both of these out of manual mode. And as the house is an active house, and as there might be a ventilation requirement, the flap will go into whatever position, okay, that is required. You can hear now, also the fan is starting. And the flap is moving, most likely. I think, Jan, if you look, you can see the flap is also moving. Slowly, but it's moving. Okay, so now we know it is not in manual mode, because if it's in manual mode, the calibration is not so easy, because manual mode would override anything. Then you can see here, we have also in the technical menu here, we have something called calibration. And there you have climate calibration and production calibration. Climate being everything with actuators and sensors and fans. And production could be, for example,
Body weight.
scales.
Yeah.
Whatever scale it is. Bird scale, feed weigher scale, or whatever.
Water scale.
So we are going for climate here. And then we say side outlet flaps. This is the flap up here. And then we say that here we can see the position of it. It is about to close. And now we say, I want this calibrated. And now you will see something interesting. Now I set the calibration on. And what it will do, it will now search both end positions. Both.
Yeah.
And it will go towards the end position until it cannot get any further. And then it will record the voltage, feedback voltage. And for example, now it's going up to 100. By the way, if it is at a position higher than 90% when we start the calibration, it will go a little bit below and then go up again in order to take care of any slack. Okay. So you see now it goes up to 100%. Unfortunately, we cannot see the actual readback voltage at the same time. But you will see that when it is fully open in a few seconds, you will see that this number does not increase anymore. Then the computer tastes the voltage, stores the voltage, and say this is 100% for that flap. And then it moves back to closing. When it's not moving anymore, it says, okay, that voltage is the same as 0. And then the actuator is calibrated. Okay? You see 99.9, it says, okay. And you can go out of this, now it set it at 100, so it said, okay, I read 99.9, but that was according to the old calibration, which was, by the way, 3 months ago, I think. I define this now as 100, and then I go the other way.
And what can be like a standard deviation? Like, I don't know, 2-3% for all the house?
Yeah, it is I think, I don't know exactly, but a few percent it can be. It is not 10%. But you can actually, here at the inlets, you can actually start the calibration of the inlets at the same time. Now, I will not do it now because the calibration for the inlets takes a long time. But actually for the inlet, when you have this manual actuator, if it was never calibrated, if you come to a system and you see that if you say no calibration here, if you cannot see ended, if you see no calibration, then you should definitely, the first thing you should do is calibrate it. But it should be calibrated. Okay?
But calibration is making by an installation company?
It should be.
It should be.
Okay.
If you come to an installation and this does not say ended for all the actuators, then they have forgotten, and that's a failure. That's a mistake. They must be calibrated. Particularly the bandio actuator, because it can be programmed to have a stroke length of anything between very few centimeters and 60 centimeters. The max is 60 centimeters. And in this case out here, we want it to, have I forgotten? Don't remember, 37 centimeters or something is the stroke length. And if you don't calibrate it, then the numbers will be way off, because here you have two things on that kind of actuator to calibrate. One which you would not do, that is the mechanical calibrator on the actuator itself. But after that, you then go and calibrate on the computer. Understand?
Yeah.
And that one on the computer you can safely do always. You should not be able to make any mistake doing these calibrations here, okay? So if we now go back and look
we
at...
do it only in automatic mode, not in manual, or both.
You should preferably not have the unit in manual mode while calibrating, because I'm not sure. I believe that the manual mode is overriding calibration. I'm not sure.
But also in the older versions, talking about it.
What?
In the older versions from Skov, we are seeing not. This is the new version, of course.
Yeah.
We have had calibration for a long time.
Yeah, calibration, but I have to check. But I think calibration was before in manual, under the manual menu, in the older versions.
Yes, that is true. In the DOL 234F, the calibration was below the manual auto things. Yeah, that is correct. But that's a long time.
The working is the same.
The principle is the same.
Yeah.
So now you can see it has ended, so it is back and it says 14%. The next thing I want to demonstrate for you, and you can try and see on your own, is side curve adjustment. But you don't want to do side curve adjustment. The reason I want to show you is, and you could use the smoke machine yourself, is to illustrate to you what I have drawn on the whiteboard a number of times, this with the air going along the ceiling, sticking to the ceiling because of Coanda effect, and then mixing up and coming around and so on. And in order to make it just a little bit realistic, I have put on heating in the house. It will cost these people here enormous amount of money, but and in order for me to decide what ventilation level we have, I will put the system into side curve calibration mode. This is a side curve setting mode where we decide how the outlet capacity is compared to the side inlet opening. Okay, I'm sorry, there's no tunnel here, so that's all.
Yeah. No.
Anyways, you would not want to do that, but I do. I show you now just for the need for presentation, for demonstration of the smoke test. Because what you have here is you have pressure curve, and then you have adjust pressure curve, and then you can say now it's off. Okay. Now I say I want to adjust the side curve. As soon as I do that, all the controllers, you know that there is a controller trying to keep temperature, there is a controller trying to keep CO2 level, humidity level. It's like there are a number of thermostats in the system. Yeah, you could call it thermostat, a popular way of saying there are a number of regulators. All these regulators are now not functioning. Well, they are functioning, but they are not allowed to decide where the inlets and outlets are going. I am. When I then go in, I can adjust the side curve and adjust curve here, and then you can see, by the way, we can see when it was done the last time. Then I can adjust curve, and now we can see that the side mode curve, when we say curve, actually what we mean is a table, but the table can be translated into a curve, and it gives you the relationship between output, so fan output capacity, in relation to inlet opening. And the pressure here is just for our notes, so that we can remember that when we did the setting, what was the pressure in this house at that time. Because if we come back and the window has broken, we will be able to see that the pressure has dropped. Okay?
So usually the output, the inlet is not the same number.
No.
To have a pressure.
The idea here is that we actually keep the inlet opening percentages as recommended by our service manual, and then we adjust the outlet capacity so that we get the right throw length of the air jet when it comes into the inlets, okay? And I will demonstrate to you, because what I will do now is I will go to a curve point 6 or something. So you can here go to each curve point, and you can see the inlets and outputs are moving. Yeah.
This point is like date or not?
No. These are just points. These are arbitrary numbers. We have, for some reason, we have 14. We have defined 14 points, with 0 being 0, or 1 being 0. You could have 10, you could have had 20. We have 14 for, I don't know why, for historical reasons. It just has to do with the granularity of the adjustment we can make. But it's simply the combination of output capacity and inlet opening, balancing.
And then you just link the curve point with
Yes.
date.
Yes. No, the day has nothing to do with it.
No, just the physical.
How much air you are taking off, and how much air you are going in.
Yeah.
Okay.
It's just the balance between the inlet and the
balance between the ventilation. Yeah. Okay. Opening.
So what you can see here is this menu in the controller is quite practical for the
Percentage.
yeah. This is percentage. The output is in percentage of nominal air, and the inlet is percentage of max opening. This menu is practical because while you are doing the settings, you can see if the inlets are at the point that we want them to be. You can see, and they are not yet there, so we are not ready. And you can also see that if the flap is at the point where we want it to be, and it is the flap is at the point where we want it to be, and the fan is running 57% of its maximum usage. Okay. So over here. We can check if we have air spinning back. Now we have a little bit, but still not too much. Only when I get out in here, within 1 meter or so from the fan, you can actually see how close, can you see how close the smoke must be to the fan?
Yeah.
If you stand to the side, you can see how close the smoke has to be to the fan before it really starts moving.
Jadi di side mode ini memang tujuannya bukan kecepatan angin, tapi dia untuk sirkulasi.
1 meter away from the fan, the speed is already down to 0.2 or 0.3 meters per second.
Okay.
Yeah, something like that. Yeah. In the right place, it shouldn't matter much where you do it. So now you can see this spark of smoke moving.
Yeah. They go to the middle.
Stick to the ceiling.
Yeah.
Is it going far enough?
Yeah.
Does it go?
Yeah. You feel that, Menir?
I feel smoke.
Okay.
Can you try from the other side and see if you think it's... I will have to stand in the middle and look. Take a little bit more.
Go to the mirror again.
You should listen to your Polish colleague here, because he says that he thinks it drops a little bit too early. It's not bad. It's not bad. Then we have movement, but
Okay.
not too much movement.
They go up.
Yeah.
There they go. Yeah.
Yeah. So you can do that to make sure that the air speed at the floor is very low.
Jadi ini untuk mastiin aja. Ya, ini untuk mastiin aja. Apakah udaranya benar-benar jalan atau enggak?
It will be pulled up by the circulation. So it will go up because of the circulation. It should do that.
And the purpose of the segment air exchange.
Yeah. Another thing that I can show you with this smoke machine here is that the airspeed, because of the fan sitting at the end, is actually not very much affected in the room as such, because normally we would have it sitting down on the side or up in the ceiling. This case it's sitting at the end, so we will say, oh, we made a tunnel. But if you look up here, you can see That's not really airspeed that direction.
Yeah, yeah.
What you see is you see the airspeed going down because of the...
Going down, and after that, yeah.
So you don't really have airspeed in that direction. I can go close. You see?
Yeah. Because the door is opening.
Yeah, but still it's pretty good for your mind.
Ya. Jadi kalau pintunya dibuka, udara itu dia tidak ngalir cepat ke bawah, tapi dia lama sekali. Ini persoalannya ada di static pressure-nya. Kita coba tingkatin kecepatannya. Lihat ya, itu kipasnya. Ya. 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 Ini udah lebih cepat kipasnya. Kita lihat arah anginnya. Oh ya. It drops faster and they go. Yeah.
The thing is, maybe this is also a little bit too fast.
Yeah.
If you do it again from the other side, and then guys, please look now. The smoke is coming. What you can see now is we are maybe a little bit to the high side, and what you can see is that the air jet from the other side is kind of like punching a hole in the smoke coming from that side.
Yeah. Yeah, they make a hole.
So this is maybe a little bit too high. Okay. So let's take this a little bit down again, but I think it's better to have. We are in the middle of the ventilation range, so we should actually have some speed.
That's nice, Fernando.
Karena ini kabelnya di atas, jadi kesedotnya ke tengah.
So, Opa, you stay in the middle.
You can see the vortex, huh?
Yeah.
Only the line 1 meter.
And then they go to the going down.
Okay, I can see you need help. Forgot the name now. Fernando. Yeah,